Okay, so I'm going to solve question number 15 on page 389. The question says, determine the coordinates of a unit vector perpendicular to A, which is -1, 2, 5, and B, which is 1, 3, and 5. So the first thing we're going to do is let the required vector be x, which is equal to x, y, and z. So this is our first step. I'm going to do that first. Okay, now we're going to take use of the property that says when two vectors are perpendicular, their dot product is equal to 0. So A dot B is equal to 0 as long as A and B are perpendicular to each other. And we're going to use that right here. We're going to say that xyz dot A has to equal to 0 and xyz dot B has to equal to 0. So knowing this, we're going to go right on and do the dot product. So x, y, z dot, okay, so the coordinates of A are -1, 2, and 5, which is equal to 0. Now, the dot product, so x dot -1 is equal to -x plus y dot 2 is equal to 2y plus z dot 5 is equal to 5z is equal to 0. Right here, we now have our first equation. Okay, now we're going to do xyz dot b. So x, y, z dot, and the coordinates for b are 1, 3, and 5 is equal to 0. So x dot 1 is equal to x plus y dot 3 is equal to 3y plus z dot 5 is equal to 5z is equal to 0. Okay, so now we have our second equation. So if we have two equations, we're going to use what we learned in grade 11, and it's a method called elimination. And we're going to use this method to solve for z. So solve for z. This is our step number 2. Okay, so solving for z. So we're going to put -x plus 2y plus 5z is equal to 0 over x plus 3y plus 5z is equal to 0. Okay, so notice here that we have a lovely -x and x, which means that we can cancel them out without multiplying it by anything. And when we add these, we get 5y plus 10z is equal to 0. Which then means that our z is equal to -1 over 2y. Okay? So we have our z value. Okay, so now that we have our z value, we can plug that in into any one of our two equations. Equation number 1 or equation number 2, and then we're going to solve for x. So let's write that down. Solve for x. That would be our step number 3. Okay, so since we can use any one, I'm going to use equation number 1, which is -x plus 2y plus 5z is equal to 0. And I'm just going to plug in my z value onto 5z. So -x plus 2y plus 5. Okay, and then I'm just going to do -1 over 2y is equal to 0. Okay, so now we have this. We can go on to solve. So I know that -x plus 2y minus 5 over 2y is equal to 0.